All right, today we're going to talk about graphing polar equations. So not just single points in the polar plane, but equations. So for polar functions, the inputs are given by theta. So your inputs are the angles, which actually come second in our coordinates. And the outputs are given by r, the radius. That's our dependent variable, which actually comes first. On the AP Pre-Calc exam, questions may use the phrasing below to introduce a polar function. The graph of the polar function r equals f of theta, where f of theta equals 3 minus 3 sine of theta, is shown in the polar coordinate system for 0 is less than or equal to theta is less than or equal to pi. Don't be scared by that. It just means, hey, we graph this function on this range of inputs. So let's graph a function. We're going to graph the function 3 minus 3 sine of theta for 0 to 2 pi. So we're going to go a little further. So we just start plugging in values. So if theta is 0, I have 3 minus 3 times the sine of 0. Well, the sine of 0 is 0, so I get 3. So when I have a 0-degree angle, my radius is 3. And on this graph, it's a little weird. We got to be right in between the 2 and the 4. Sorry. All right, how about pi over 6? 3 minus 3 times the sine of pi over 6. You know what? Just for fun, let's turn that into a decimal. Friendly calculator reminder. If I set my function to be 3 minus 3 sine of theta, well, x, right? And then I just have to say y1 of pi over 6. Look at that, my answer is 1.5. Now I can quickly find second entry, pi over 4. There's my answer, 0.879. So I can very quickly fill in this table using that shortcut. So pi over 6, let's see. With the way this graph is drawn, this first line here for an angle is pi over 12. Then pi over 6, pi over 4, pi over 3, and then 5 pi over 12. So let's be careful there. All right, so I have pi over 6, 1.5. Well, let's see here. 1.5 is about there. Pi over 4, 0.879. So let's see here. 1's going to be about there. How about there? Pi over 3. Let's type it in my calculator. I get 0.402. Maybe there. Pi over 2, I get 0. Any coordinate, any angle with an r of 0 is going to be right there on that origin. All right, let's try 2 pi over 3. I get 0.402. So 2 pi over 3, about there. And 3 pi over 4. Just type in each of these in my calculator as we go, 0.879. And 5 pi over 6 is going to give me 1.5. And pi is going to give me 3 again. Now things start to get fun. 7 pi over 6. I get 4.5. 7 pi over 6, 4.5. 5 pi over 4, I get 5.121. About there. 4 pi over 3, I get 5.598. About there. 3 pi over 2, I get 6. And I keep plugging in. 5 pi over 3, I get 5.598. 7 pi over 4, I get 5.121. 11 pi over 6, I get 4.5 again. And at 2 pi, I get 3. I met up with that first point I drew. Now you have to connect your points in order, and sometimes it's a little tricky if you just made all your points and then want to connect them at the end. Sometimes it's a good idea to connect your points as you go. But my points went in order, just like this, making this fun, funky graph. Notice it's not a function as we would define on the standard XY coordinate plane, but it is a function on the polar plane. On the AP Pre-Calc exam, polar functions will only appear in multiple choice questions. That means you will not be required to sketch a polar function by hand on the AP exam. However, you will be expected to understand polar functions, their graphs, and what portion of the graphs exist with various domain restrictions. When working with multiple choice questions involving polar functions, it's advantageous to evaluate the function at several values of theta. Utilizing the multiple choice options can be helpful when determining which values of, that's supposed to be theta, to consider. So what we're going to do is we're going to say which function is this. And now we just need to choose some values of theta to check. I would never check anything that has a coordinate of 0. Don't do that. It's not helpful. But looking at this, I can see that right here, this will be pi over 6, and it should have a y value of 3. So I say, all right, 3 times sine of pi over 6, 3 times the sine of 3 times pi over 6. In my calculator, that says 3. So that one's still on the table. The second one won't say 3. Third one won't be 3. Fourth one won't be 3. I only had to check 1 point, and I know the answer is A. If I hadn't gotten to that point, I would have said, okay, well, pi over 4, I should get like 2 point something pretty small, 2.1-ish. And I'd check those ones. Let's try a little bit more complicated of one. We're going to figure out what trig function this is. So I would start here. At 0 radians, I should have a radius of 2. So that rules out C and D. Because the cosine of 0 is 1. So this would give me 6, and this one would give me negative 2. I'm probably going to rule both of those out. Also, I can't rule anything else out. Sorry. So then I would check pi. All right, well, the sine of pi is 0. Oh, those both give me 2 anyway. All right. Right here, I could either check pi over 2 or 3 pi over 2. It could be either one. So remember that you might get a positive number or a negative. So I'm going to type in 2 plus 4 times the sine of pi over 2. I got 6. Well, pi over 2, 6 would be right up there. And that point does not exist. So let's double check. I'm pretty sure at this point that it should be B. 2 minus 4 times the sine of pi over 2. That gave me negative 2. Well, pi over 2, negative 2. Oh, that is my point. It is actually going to work since it was negative. If I plug in 3 pi over 2, I'll get that 6. So my answer is B. Another little piece of this is that you can graph these on your graphing calculator. It just gets a little wonky. So we have to change our mode from func to polar. And then we go to y equals, notice it switched it to R1. So let's go 2 minus 4 sine of theta. And it types in a theta now for me instead of an x. And then if I hit graph, yowza, I don't know what that is. Zoom 6. Look at that. There's the graph I just drew, or I just saw. But make sure also, always change your mode back to func so that you don't get stuck there.